Hello, and welcome to our educational series on a fascinating world of computer systems. Today, we are embarking on a journey to explore an often overlooked yet crucial aspect of technology, which is called legacy systems. These systems are the unsung heroes of the tech world, holding the fort in many organizations despite the rapid advancement in technology. Join me as we delve into what makes these systems so important, the challenges they pose, and how they continue to evolve in the ever-changing landscape of information technology. Whether you are a student, gearing up for an exam, or just a tech enthusiast, this deep dive into legacy systems is sure to shed the light on some of the foundational elements of our digital world. So let's get started. So, what does it mean when we say legacy systems? A legacy system is a term we often encounter. It refers to older software and hardware still in use today. These systems are unique as they utilize languages and technologies no longer prevalent in new software development. A key aspect of legacy system is the reliance on older hardware, such as mainframe computers, which may not be compatible with modern technologies. But legacy systems are not just about software, they are broader socio-technical systems. In other words, legacy systems are complex and interconnected systems that involve both technical and social aspects, including organizational procedures and practices associated with them. This means they encompasses not only the hardware and software, but also libraries, supporting software, and business processes that have been built around them over the years. Understanding legacy system is not just understanding old technology, but grasping the complex interplay of technical components with established organizational procedures. Moving to the next slide, we have the elements of legacy systems. Building upon our understanding of legacy systems as socio-technical entities, let's dissect the elements that compose these systems as illustrated in this diagram. At the foundation, we have the system hardware, which may include outdated machines like mainframe computers. This hardware underpins the support software and ensemble of tools, possibly now obsolete, that sustain the application software, the heart of business services. Interwoven with this is the application data, often scattered and inconsistent. These technical components are governed by business policies and rules, and together they facilitate business processes. Each element has a symbiotic relationship, creating an ecosystem where the software and business side must coexist harmoniously. As we transition from the theoretical constructs to the concrete makeup of legacy systems, let's scrutinize their key components. First, we have the system hardware. These are the original machines for which the legacy systems are crafted, many of which are no longer in production. Then there is the support software, which is an array of utilities and services, many of which have become obsolete or lacking ongoing support. Then we have the application software, which is the driving force of business services, often consisting of a suite of individual programs. Finally, we must consider the application data. This is the information processed and managed by these systems, characterized by potentially inconsistencies or duplications, and even sometimes distributed across various databases. Continuing with examining the components of legacy system, we must acknowledge the business processes and policies they embody. These systems are often the bedrock and upon which business processes are structured, designed even to achieve specific objectives. However, they can impose constraints due to their inherent limitations. Furthermore, business policies and rules, principles dictating operations, and placing constraints on the business are frequently interwoven with with the use of these legacy systems. Recognizing and navigating the intricacies of these limitations is crucial for any modernization effort. Next slide, in this representation of legacy system layers, we see a structured model that is central to understanding the socio-technical compositions of these systems. At the base, we have the hardware, the tangible foundation on which everything else is built. Above it is the platform and the infrastructure software, which provides the necessary environment for application software to function. The application software layer, where core business functionalities reside, interacts directly with the business processes at the top of this hierarchy. These processes are the operational activities that fulfill the business's objectives. This layered model is integral to the analysis, maintenance, and modernization of legacy systems. Moving to the idea of replacing these legacy systems. Replacing a legacy system is a complex and risky and often costly endeavor for businesses. This is primarily because such systems are deeply interwoven with business processes they support. The risks include not having complete specifications for existing systems, which is crucial for creating new one that can match or improve upon it. Moreover, the tight integration of the system with business processes and undocumented business rules that are often embedded within the legacy system can pose significant challenges. Additionally, new software development projects replacing legacy systems frequently run the risk of delays and even exceeding budgeting. Further adding the risk profile for such initiatives. Well, how about the idea of changing these legacy systems? Legacy systems are often costly and challenging to change. One reason is that the code may lack a uniform style, making it difficult to understand and modify. Another issue is that these systems are typically written in outdated programming languages, and today, few programmers have the skills to work with these languages, increasing the complexity and, of course, the expense of any changes. Now let's move on to how do we manage these legacy systems. In managing legacy systems, organizations must carefully consider their strategy for evolution. They can opt to discontinue the system and alter their business processes accordingly, maintain the current system with ongoing support, or re-engineer the system to enhance its maintainability. And the last resort, which is to replace the system entirely with a new one. So you might ask questions. What is the optimal strategy to deal with these legacy systems? I would say the optimal strategy should be based on a thorough evaluation of the system's current performance. Also to look at its integration with business operations and its overall value to the organization. So moving to the next slide, this diagram, figure 9.30, and illustrates a legacy system assessment based on two axes: business value and system quality. Systems in the top right quadrant exhibit both high business value and quality, indicating they are well suited for continued investment and use, of course. Bottom left quadrant systems have low business value and quality, suggesting they might be candidates for decommissioning. Top left quadrant systems, despite having high business value, have low quality and may need significant re-engineering or replacement. Finally, systems in the bottom right quadrant, while of a high quality, offer low business value and may be maintained less aggressively or phased out completely if they no longer serve a critical business need. In our last discussion, we examined the assessment of legacy systems, framing them within quadrants of business value and quality. Now let's address the strategic choices for each category. For systems that are low in both quality and business value, the straightforward approach is to, scrap them, and because they offer actually a little benefit and are not worth the investment. When we encounter systems that are crucial for business yet costly due to poor quality maybe, re-engineering or replacement is the prudent path, provided a suitable alternatives exist. Systems that function well but do not significantly drive business may be replaced with off-the-shelf solutions or simply maintained as necessary. Finally, those systems which score high on both fronts are the keepers. They are to be actively maintained, continuing their operation as valuable assets in our technological infrastructure. As we conclude this segment, we have navigated the intricate landscape of legacy systems, understanding their role and the strategic thinking required for their evolution. It's a delicate interplay between preserving valuable technology heritage and steering towards future innovations that guides our approach. I hope this session has enlightened your perspectives and equipped you with the knowledge to face such technological challenges. Join us again as we continue to unravel the complex tapestry of information technology that shapes our world. If you have found value in our exploration today, consider subscribing to our channel for more insight. Until then, keep innovating and questioning the status quo.